Hey guys. All right. So today we're going to be talking about your very first chapter in the physics component, which is physical quantities and units. All right. Um, okay. So when we're talking about physical quantities, let me quickly write that down on the board for you guys. So it's physical quantities and units. Right. So when we're talking about physical quantities, a physical quantity is basically anything that can be measured or calculated. Alright, so before we get into the chapter, we need to know what physical quantities are. Alright, so physical quantities are those quantities which can be measured and calculated. Alright, so um, So when we're talking about physical quantities, it consists of obviously a numerical magnitude and obviously the unit, right? So what do I mean by numerical magnitude? A numerical magnitude basically states us or gives us an idea of how big or how small something is, right? So let's suppose if I tell you that, okay, that this thing measures about 5 centimeters, and object A measures 5 centimeters, and we have another object which measures object B about, let's say, 20 centimeters, right? So 20 and 5, these are the numerical or just simply magnitudes. Alright, and cm or centimeters that you guys can see here, this is your unit. We're going to study about units further and later on in the chapter. Okay, so clearly by looking at these values, you can state that object B is much greater than object A, right? Why? You just look at the numerical value, you just look at the numerical magnitude here, and you can obviously tell that, okay, we know that 5 is smaller than 20. That means that object B has to be greater than your object A. Okay, so all physical quantities are consistent of one, numerical values, and two, your units. Alright, so we know what numerical values are, very easy, something that we've been doing so far, that in math we have numbers and stuff like that, right? When we come to units, units it's a slight different thing. Maybe we know what units are, but we haven't really given a name to it. But let me tell you what exactly these things are, right? So when we're talking about units, units are basically that particular annonation or the name that's given to a certain something, which consists of symbols and a certain value, right? So let's suppose if I talk about 20 centimeters, you would automatically know I'm talking about the distance or the length of something, right? Similarly, if I talk about 20 seconds, right, you'd know that, okay, right now I'm talking about time. Okay, so a unit is basically something, a symbol that we add to a number, all right, or we add to something so that we can give it more meaning in terms of what it actually is we're talking about. All right, so what have we studied so far? That physical quantities are measured and they're calculated. They consist of numerical magnitudes and they consist of units. All right. So now we're going to talk about the two different types of quantities that we have. So in physical quantities, there are two things that we study. They're base quantities, and we have derived quantities in here. Alright, so base quantities and derived quantities. Okay, so when we're talking about base quantities are those quantities which cannot be further derived from anything. What do I mean by that? So let's suppose, let me walk you through a couple of examples first, and then we'll get into a little bit detail of what this actually means, right? So base quantities are those quantities, okay, which cannot be derived from other quantities. For example, we can include length, we can include mass, we can include time, and also temperature, etc. Alright, so base quantities cannot be derived from other quantities. What do we mean by that? It means that these quantities basically exist in their very truest forms. Okay, they exist in their very truest forms. Why? Okay, so let's suppose we have, I'm sure you must have studied in math or somewhere that, area, how do you calculate a certain, area of an object, of a, geometrical object, let's suppose square, right? You multiply the sides. Alright, for perimeter, what do? You add all the four sides of a rectangle or a square, right? So you'd say that area is made up of two lengths. The perimeter has four sides or four lengths, right? So area and perimeter, these are basically those quantities which are derived or which consists of other base quantities. Alright, but base quantities are not made of anything. They're just there. They're there in their very purest forms, right? So when we're talking about area and perimeter, we obviously give them different names. Area and perimeter, and other similar quantities like volume, like force and stuff like that. We give the moments. I'm sorry, we give them a different name. All right, we call them derived quantities. What do we call them? We call them derived quantities. Okay. Right, and what do we know about derived quantities so far? So derived quantities will be those quantities which can be expressed by combining suitable base quantities. For example, let's see, we have force, we have volume, we have area, we have energy. I'm going to talk about what these components are made up of. So when we're talking about force, force equals to ma, mass, which is a base quantity, and acceleration, which is a derived quantity, once again consisting of other base quantities. Alright, so force is a component of mass and acceleration. Similarly, when we're talking about volume, it depends on what shape we're implying it to, but the basic would be length into breadth into height for a cuboid, or length into length for a cube, right? Similarly, for area, depending on the shape, let's suppose if it's a rectangle, we'd say that length into breadth. All right, energy, once again talking about, let's suppose we're talking about kinetic energy. We're different types of energy, obviously, right? We have strain energy, we have kinetic energy, we have potential energy and stuff like that, right? So energy would obviously refer to that. So we have half into mv square for energy. We have half mv square. So m over here is the mass, v would be the velocity. Alright, and this would give us, this is basically a component. Energy itself, or kinetic energy itself, is a component, or is a mixture, or is a, is achieved by combining mass and velocity square divided by 2, or half of that, right? So once again, I hope that makes a little more sense to you, that when we're talking about base quantities and derived quantities, so base quantities are those quantities which we are not able to derive from anything. They exist in their very purest forms. However, when we're talking about derived quantities, they're more dependent, or more, described as of those things which are derived, or which are compressed, or which are, which consist other different objects or other attributes to it, right? Which is obviously going to be your base quantities, right? So that's it for base quantities and derived quantities, which are two different types of physical quantities. Obviously, we have both one thing or two things in common, that all these base quantities, all of these derived quantities are something that we can physically see and something that we can physically measure, and obviously we can calculate them in different ways, obviously, right? So there's that's that about physical quantities. Now we're going to talk about what SI units are, right? So earlier on, I believe you remember what we talked about in terms of the units, right? So SI units are basically, let me just tell you the full form of it. So it's called Systeme International. All right, so, or it's in other words, it's basically an international statement or international system of quantities. All right, you can call it this, call it international system of quantities. Okay, so as we know what units are, we know what the basic thing is, right? Now when we talk about SI unit, so SI unit is basically more of a law or more of a regulation kind of a thing, so that everyone, no matter where they are in the world, they are on the same page, right? So when we talk about length, or let's suppose when we talk about time, the SI unit of time would be seconds. The symbol we use for second is just small s, right? So why do we say that time is the base unit, or the SI unit of time is seconds? What do we mean by that? We mean by that okay, according to the laws, according to the international system, no matter where you are in the world, let's suppose you're in London, let's suppose you're in the UAE, let's suppose you're somewhere else, wherever you are in the world, if you go up there, you talk about, you talk to somebody and you ask them what, how long before the movie starts, right? They'd say that, okay, we just have about like, okay, 40 seconds before it's starting, or a minute or something like that, right? So you'd know what this guy is talking about. You'd automatically be able to understand what this guy is saying. Okay, if he's saying that, okay, we have like 15 seconds before the race starts, right? So the 15-second thing is basically applicable, or it's understandable throughout the word, right? Similarly, when we're talking about length, right, you go up to a carpenter and you say that, okay, I need this piece of wood to be extended by another 100 centimeters, right? So no matter where you are, you're in London, you are in the UA, you are in the US, wherever you are, you'd know what you're talking about. You'd know, okay, this guy is referring to the time or to the length, because obviously you stated that you need to extend this by 100 centimeters, right? So just because of the SI units, just because of this law, just because of this system, it has become very easy for us to go out and make sense of something. All right. So similarly, obviously, it's not like we only have, we use seconds to understand or relate to time. We have minutes, we have hours, we have centuries and decades, and all those stuff, right? But once again, those are also, when we're talking about minutes, when we're talking about hours, they are also different units that we use to describe time. But once again, those minutes, hours, these are not your SI units, or the very basic base units that we use to describe something, right? Obviously, when we're talking about length, we have kilometers, we have centimeters, we have meters, we have you know uh, different other similar units that we use, right? But obviously we need to have one thing that everyone knows. Okay, by this guy means this. All right, so that's basically why we have SI units. We have a separate table for it. There's a table that you will be that I will be including in these videos, that you will have to learn. You'll have to memorize those, which are very easy. I'm pretty sure most of you already know half of those half of those values or half of those units. Okay, and yeah, so that's it for today's session. I hope you guys were able to make sense of this. We're going to do a little more detailed videos on the chapters that we're going to be including in our next sessions. All right, so this was it. It was a very basic and a very introductory session about what your physical quantities are. Obviously we have a lot more things to discuss. We have vectors and scalars. We have we have how exactly we use different types of different methods to find out the resultant vectors and stuff like that, right? So we're going to be covering those things in the next session, hopefully. So yeah, please do let me know if you have any questions about anything about whatever we've discussed so far, and I'm always here to answer them for you. All right, guys? Okay, perfect. So yeah, take care, guys. I'll see you guys in the next session. Take care. Bye bye.